All right, so today I'm going to talk a little bit about systems. Some very easy systems, okay, where x and y depend on one another. These will be the very first ones we do. We will do more. There are some that are going to be very easy to solve. We already looked at an easy tank problem, right? So that was a systems, as a matter of fact. A couple of ones we're going to do right now are very easy as well. So let me come up with this one here. And this, of course, your book usually writes x prime equals y and y prime is x. But either way, it's fine. Now, a couple ways to solve this guy. So we're going to talk more about them as we go. But the first way, and if it's nice, if it works this way, is to do this. Hey, look, so y is equal to x. That means y prime. Oops, I'm sorry, I wrote it wrong. Sorry. Y prime is equal to x. That means y double prime is equal to x prime. Did you see that? Nice. Well, wait a minute. Y double prime then, because x prime is y double prime would equal then, would equal y. That's right. And therefore, I would end up with this guy, which is a homogeneous second order, bam. And so, of course, this is r squared minus 1 equals 0 like we've been doing. R plus 1, r minus 1. And so, of course, we have the formula. So we say y is equal to C1, right? E to the negative t, because this is negative 1 and this is positive 1, plus C2 e to the t, like so. That's great, Jay. That's what y is. What's x? Hey, I'm glad you asked. Because check it out. X is equal to y prime. So negative C1 plus C2 e to the t. And friends, we're home free after that. Now, somewhere I probably told you an initial condition. I didn't yet. But I'm going to pretend like I did. And so if that were the case, then I'd have C1 plus C2 is equal to 0, or 2 rather. Negative C1 plus C2 equal 4. I'm just going to solve this. If you're going to do it on your calculator, don't pay attention to what I'm doing here. I'm going to add, so that's this is this, so T2 is 3, which means C1 is negative 1, right? So then my equation would be negative 1 plus 3, and this would become positive 1, of course, and that's my answer. Piece of cake. Now, question is, could I do it another way? And of course the answer is yes, because that's what we do. And so, when we start doing these guys, we're gonna in the next chapter, we're gonna start talking in chapter 5. We're gonna talk about eigenvalue method for doing these. Okay, and so in reality, we're gonna still get the same equation at r squared minus 1. We're gonna come at it from a different point of view. So, tonight what we're gonna do primarily in this video is just some cute little algebraic manipulations like we did. Okay, but what we're also going to look at. Wait a minute. This is a systems of equations where we said x of 0 was, I think, 2 and y of 0 was 4. Hey, could we do Euler method for this guy? I feel like we could. By the way, we could also do Runge-Kutta. I don't think I'll do it for this one, so I'm just going to go first of all and grab a nice Euler page. Okay? And so what I'm going to have here is, all right, again, t x, y, dx dt, oops, dt, stupid, dy dt, and of course our step size. I don't know, I'm going to choose 0.01 just for grins. I like that, it makes me happy. I have small dreams. There we go. 0. This is going to be equals, now remember, dx dt was equal to y, right? And dy dt was equal to, that was equal to x, right? So then here I'm going to say equals, step. Oops, what am I doing? Equals 0 rather. I didn't hit save it as step, so I'm gonna do this. I'm just gonna put my dollar signs in instead. You can do it either way you want, whatever works for you. Okay, and then of course I can drag this down. Maybe I'd like to predict for 2, or no, I guess I'm gonna hit 4. I'm just gonna predict for 4. Oops, what happened? I feel like, oh, we just oh, what an idiot. Try that. There you go, dummy. All right, I bet it'll work now. There we go. What an idiot. All right, so equals. Okay, so I'm going to take the previous value plus the slope, right, times my step, which is this $sign F $sign 4. No, 2. There you go. Bam. And then, of course, this guy is going to be equals this fella plus slope times $sign F $sign 2. Yep, that's good. And bring these two, highlight them down like so, grab them all. Oops. Give it the old double tap. Voila. And what you'll see is when you get down here, you'll get to that. Now, how close am I to the right answer? Well, I don't know. So, on the previous page, where's my notes? Previous page, minimize, minimize. Where's my calculator? All right, where is my notes? So, what? Nobody told you to open that piece of junk machine. All right, so if I do negative e to the negative, now remember we're evaluating at 4, right? Plus 3 e to the 4. Should get 163. Is that right? Yeah. Oh, I left off at 0.4. Okay, well, we'll go to 4 on the other page in just a moment, please. Holy cow, I'm having one of those days, people. Ever had one of them? Wow, I've had one. So, 163.77 and 163.81. So that's what our values should be. And if we actually do it right in Excel and actually, I don't know, pull it down to, 4, not 0.4, I bet it'd actually work. Today I was getting ready for my differential equations to high school, and they're doing something that you haven't done yet, but you're ahead of them in another aspect, whatever. And you're going to see it not next week. Well, yeah, I think next week you're going to see it. I think it's next week. Anyways, whatever. It takes a lot of planning. You can really screw it up easy. So I'm sitting there at my desk during my prep period working on it. And these two girls come in. Can we get some help? And of course, being the nice guy, I helped them. And then, oh, yeah, awesome. Guess what? I didn't get to prepare my notes all the way. And yeah, I was off. And it was so horrible. Anyway, 160. And the calculator said 163. Hey, that's pretty good, obviously. That's 0.01. I could have gone 0.001. There it is. Not too hard to do. Again, could do the same thing with Runge Kutta. We will do that later today. I don't want to do it this instant. I'm going to try another one. See what you think about it. So, there we go. Oh, hey, that's kind of gross. It is kind of gross. You're not wrong. So, interestingly enough, what a person could do is go, well, crazy. Excuse me, dying. Okay? Well, first of all, I think this is also true. Right? And then I think if you take the derivative of both sides, I believe this is also true. That makes me pretty happy. So right here in place of y prime, I could literally put in negative x double prime equals 10x minus 7y. But wait a minute. Y, you see, is x. Negative y is x prime, or y is x negative x prime. Whatever makes you happy. In either case, this is going to become this. And then, of course, if you bring this over to the other side like it belongs, so it's positive, right? Hey, that factors. Cool. Let's do it. So that's r squared plus 7r plus 10 equals 0. R plus 5, r plus 2. So negative 2 and negative 5. So when I do this, I know then I'm solving. Notice I solved for x this time. So x is going to be equal to c1 e to the negative 2t plus c2 e to the negative 5t. That's nice. What's the relationship between y and x? Y is negative x prime. So let's do x prime first. So if I take the negative of that, I get y prime, not y prime, y is 2c1 plus 5c2. And so there are my two equations. Again, I was told that there are 2 and negative 7. So c1 plus c2 is 2. 2c1 plus 5c2 is 7. If I times the top, I'm just going to go ahead and solve this. You feel free to hit solve on your calculator. I'm just going to do it this way if that's all right with you. I'm going to subtract. I'm going to get 3c2 equals 3. I get c2 is equal to 1. I didn't write this problem. That's why it came out so nice. And so it's just 1s. So that's my x. And that's my y. And I'm done. Ta-da! Not too bad. Now that's a little sleight of hand, and it's really nice when it works. And can it always work? Well, yes and no. Yes and no. For instance, if you got a particularly ugly one like this one, and I'm not going to solve this one tonight just because I don't want to right at the moment. No, yeah. Or something. All right. Now, if you were watching a minute ago, you know, we say, well, okay, you could do some just some different magic. For instance, you can do this: y equals x prime minus 3x. That's true, right? From here. So down here you could go, okay, well, y prime is 2x plus 3 times y. Right? But you still got this dumb y prime. So, well, that's easy to fix. Y prime is equal to x double prime minus 3x prime. Okay? And so I'm going to bring everything to this side. If I bring the x prime, I'm going to get minus 6x prime. This is minus 7 here, so if I bring it over, it's going to be plus 7. X equals 0. Oh, well, the quadratic formula always works, as you well know. Right? That's the square root of 8 in there. So that's 2 square root of 2. So these are our eigenvalues, or I mean our solutions rather. And so when it's like this, okay, excuse me, I'm not going to leave it like that. That's just disturbing. So I'm going to get my calculator and get an approximate value for that. And you could get as far out as you want to, of course. 3 plus the square root of 2. Oops, did I hit? Yes, I did. There we go. 4.14, which I should have known, come to think of it. Something like that. Oh, that's a 2 actually, isn't it? Sorry about that. Nice. Now, 1.587 or something. Okay, now of course, round that as much as you want, but what we're saying is this: x is equal to c1. I hate when it does that. Freaks me out. Stop it. Ah! Do you see that it keeps moving it over? It freaks me out when it does that. So that's x. Okay. Now what is y? Well, y is the derivative of x minus 3 times x. Brother. So there's got to be a better way. Yes? Well, okay, maybe there is, maybe there's not. So I'm going to do it. I'm going to go ahead and do it this way because it's not terribly hard to do it this way. Minus, and then it says minus 3 times x. Well, what is 3x? Well, 3x would be 3c1 e to the 0.42 t minus, because I'm subtracting the whole thing, 3c2 e to the 1.587 t. Okay? Now, if you collect your like terms, that's going to be like 1.42 c1 e to the 4.42 t. And then 1.58, that 1.42 or something, negative 1.42 or thereabouts, C2 e to the 1.587 t. This is y. And I think I'm going to stop right there because I think once you get to here, hopefully you can go ahead and solve for your C1s and C2s yourself. Well, what the heck, I'll just go ahead and do it. Don't be lazy, Jay. So the values are, oh, didn't even tell you initial conditions. Go ahead and find them. I dare you. I don't know. Who knows? So if I do that, I get C1 plus C2 is equal to 4. And I get 1.42 C1, right? Minus 1.42 C2 equals negative 3. Now, that's not too bad to do by hand, but I'm just going to go ahead and review how to solve it on the calculator. So solve. Again, I'm just going to use x plus y because they're on their own deals there. It's easy. Second, 588. 1.42x minus 1.42y equals negative 3, comma, squiggly brackets x, comma, y, squiggly brackets, parentheses, done. Bam. So x is so C1 is 0.94. And 3.05. Okay, so simply plugging them in. So 0.94, 3.05. Yeah. Oops. And 1.33. 1.33 and 1.33 and 4.33. Ta-da! And there you have it, friends. You've solved a system of equations. Doesn't seem too bad. Seems actually not bad at all, really, to be honest with you. Now, I would like to try one more here, just for fun, because, well, that's what I do, right? I mean, you know, this is my idea of fun on a Friday night, right? So maybe have x prime is equal to, and I'm going to pause for a second, make sure I get one that works exactly the way I want it to. All right, we're going to try this one. Pretty sure it works the way I want it to. We're just going to find the general solution this time. We're not going to put the C1s and C2s back into it. Okay, just to see if we can pull this off a little bit. Okay. So I'll be interested to see how it turns out. So I know that y is equal to 1/5 of an x prime. So this becomes negative x plus 1/5 of an x prime is equal to y prime. Well, y prime is equal to 1/5 x double prime. Well, if you bring everything over to this side, and then times everybody by 5, because I don't like fractions that well. I don't have the patience for them anymore. Let's get rid of the blame things. So that's r squared minus r plus 5. So we're going to have r is equal to the opposite of b plus minus the square root of 1 minus 20. That's disgusting. Over 2. So it's going to be a half plus or minus the square root of 19 over 2. I. So we good there? Nice. Okay, so if you follow me to here, we know that when we had those last time, we know it's going to be of the form e to the at parentheses c1 cosine square root of 19 over 2 t plus c2 sine square root of 19 over 2 t, like so, right? And, well, oh shoot, well, e to the at, so 0.5 here. I went ahead and put it in anyway. So that is what my x looks like. This is what x looks like. We know that's what x looks like. Okay? Well, that's nice. What's y look like? Well, according to the recipe, y is 1/5 of the derivative of x. Ah! So this is what I'm going to do. Because I really don't like taking derivatives if I'm not doing a Calc 1 class, to be honest with you. They're not that fun to me. What I'm going to do is I'm going to go e to the negative 0.5 t, okay, times parentheses. Then I'm going to put a y where there's a c1 times the cosine of square root of 19 divided by 2t, parentheses, plus I'm going to put a z times the sine of the square root of 19 divided by 2t, parentheses, comma, t, parentheses, cross your fingers. Yes, and it works. Okay, now, please understand that is absolutely disgusting what's happened there. Okay, this thing out front, this 0.6 right there that you see is e to the 0.5t. Okay, for whatever reason, the calculator decides to, quote unquote, help you out, Jay. We're going to help you. Won't that be fun? Not really, no. So what I have right there is the derivative. It's absolutely disgusting and gross. There's no good way about it. It is nasty looking thing. Ugh. 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 But not to fret, because remember what the recipe said. It said to take 1/5 of that. Oh, so you mean I have to take this disgusting mess right here, clear this. I have to take this thing here and divide it by 5? Exactly. So that thing right there is what you're telling me is what I have when I plug in, when I take 1/5 of the derivative of x, and that's what y is. That's what I'm saying. So watch this. Right now, man, it looks grim for the home team. But if you do such that t equals 0, you're left with that guy right there. Now, you're like, that's kind of gross. Well, it is kind of gross. There's no two ways about that. Notice that this 4.5 business comes about because we had the square root of 19 over 2, and it simplified it for us, and it made it, quote unquote, better when it took the derivative. I don't think it's better, friends. But it is what it is. So watch this. I'm going to go solve. Now, what happens when I plug into this thing, t equals 0? I get c1 plus c2. Isn't that cute? Equals whatever it equals. I said I wasn't going to do it. I think I said I'm going to do it. I wasn't going to do this for you on this one, but since I made this problem up, it's disturbingly gross. So I'm going to go ahead and do this one this way. So in my calculator, I'm going to go, let's solve x plus y equals 1. And this mess equals, oops, now we gotta be careful. I use y and z, so I gotta be careful. Equals 4. Okay? Oops. Should be of 0. Glad you caught me on that. Alright, comma, and now we gotta be careful because I gotta go back and put this in. I'm gonna go back and make them both y's and z's. So I apologize for that. Go back to the front, stupid. There you go. It should be y plus z. And there they are. So y, which is C1, is negative 6.65. Okay. And ouch, my leg hurts. And z is 7.65. That is C2. Okay. Now, so like that, right? Well, what's y then, for goodness sakes? Well, let's go back and check it out. So, if you come back into the calculator, you took the derivative of it up here somewhere. Somewhere you found the derivative of, there it is, and then this is where you divided the thing by 5, correct? Boom, there it is. So that is what it is, you see, when I have, that is what the derivative ends up being, is this guy right here. That is what y is. But check this out. I can also do this, such that y equals negative 6.65. And I can also do such that z equals 7.65. So you end up with this mess. Now this is not wrong. It's not even close to being wrong. It's actually really just fine. It's not 100% correct. Nothing wrong with it. Notice what's happened is they've just distributed some stuff out of it. Okay? There's that big number out front. Okay, well we know this part right here is e to the half t. Okay? And I know I've got a cosine here. And I know I've got a sine over here. Now, you're like, isn't there an easier way to do this? There's a different way. Is it easier? I'll let you be the judge of it. We're going to look at several other ways to solve these next week. Why do I need more than one? Well, I like to have more than one tool in my toolbox. I find it very annoying to have to just kind of sort of make something work. I find that very obnoxious. So notice it's just 334 right here, because that's a 1 in front. And then what's in front of, what's in front of the sign? Negative 0.22. So negative 73. Okay? These are the systems that will solve that thing. Okay. Notice that it is increasing in size, so it's going to keep expanding. Both of them will just keep going up and up and up and up and up and up. And that's great. Now, I'm going to pause you for just a moment, and I'm going to open up my Runge Kutta from the other night and do some work to get it kind of preliminary set up before I show you Runge Kutta for a system. It's no different really, you just got to be a little trickier with the thing. Okay, so I pulled up the Runge Kutta worksheet from the other day, and it's still basically set up from that the other day. So all I did was I inserted column C. I'm going to put Y's in column C. Okay, and so what I'm going to have to do is I'm going to have to reduplicate my dx dt's, but except for I need to do it for dy dt's over here. So I'm going to have a dy dt, and that'll be equal to, if you will, my k1 for these guys, right? And then of course there's going to be a k2 for these guys, and a k3 and a k4, just like over here. And of course when I'm done, I'm going to average them, average the k's for the y's, right? Boom. And it'll be the same. Obviously, this will just be equals average. You can do that right now of these 4 cells, right? Which right now is a big fat 0. Oh, no, you can't divide by 0. What do you mean you can't divide? Well, ignore that for right now. Here, I'll put a 9 in there. Oh, yeah, no, I don't know. I don't care what it is. I'm going to fix that in a minute. Okay? Now, let's start thinking about this here. We need to talk about our functions. So, our functions are x equals 5y. You see that? That's huge. So let's start building on this guy first, then we'll look at the other one in a second, okay? So let's come back into this. So my dx dt right here needs to be equal to, notice right now it is currently 0.02 times the x. That's not what I want, friends. I want just to have 5 times just what my y is. That's it, 5y. That's it. Okay? That's it. Okay? So now, over here on this one, okay, remember I want to deal with my y's, which is what's in C2 currently. And so, but it's going to be the new y. So it's going to be 5 times my new y. Well, my new y is my old y plus, right, my delta y. We don't have a delta y yet, but it's going to be there in a couple of minutes, I promise you, times my step. Okay, and I'm going to go ahead and put in that there and there. Okay, and but divided by 2, right? Right. Bam. Okay, now of course it didn't change because of course right now my dy dt is a 0. So okay, keep that in mind again. Now wait, so look at this guy right here. So there it is, that's half of your step size, yes? So that's what we have going on. That's what I have going on right there. Half my step size. Now look at the third one over. It is, what's happening here? Now, this time, excuse me. Yeah, so there it is right there. So, that's good. Now, you'll recall, somewhere down here I made note of them. Right. So, what I need to do, you see, is this is what we're going to do. So, the first time we went over half a step size in the x, half a step size in the y, right? But since our x only depends on y, that's all we had to worry about was this bit right here, this part here, this b2 plus this thing right here. That's all I had to worry about, okay? Now the next one, okay, is the same deal, except that we're going to be using the third, we're going to be using, b2 plus d2, right? In other words, well, a minute ago that was this. So a minute ago we're going to be using, so for this guy, right, we used, oops, that's not what I wanted to push, darn it. All right, let's try it again, okay? So remember last time, this was all in terms of just the y, we only had one variable last time. It was just in terms of the x's last time, okay? And so it was, so it was the original x. The next time we go over, it's going to be the new y, okay? Based on the second slope, right? Based on the second slope over, okay? The second slope is based on the first slope. That's what I meant. Now the third slope is based on the second slope. Okay, but again, it's at half of the step. And the fourth slope, as you see, is based on the third slope, but it's at the far end, the full step. So here we go. This one is based on on K1 for the y values, though. So okay. The next one is going to be based on, well, let's get rid of all this mess because that's gross. So it's going to be equals to 5 times, parentheses, the original y, which is here, plus half of the step, so 0.5 times that guy, all right, times second slope. Oops, yes. Now, again, this is off the, the first slope is just 5 times the y. This guy is 5 times the new y. This one is 5 times the new y, but notice how they're based on always one less than the slope. So the third one's based on the second slope. Now the fourth one is going to be based on the third slope. But it's going to be like this. It's going to be 5 times, again, the original y value plus a full step this time though. So if you look at this, uh-oh, what just happened? Oh, I clicked on the wrong one. No! Click on that guy, right? See, that's L2, that's K2, J2, and that doesn't have anything in it at all about those guys. Okay? Now, let's start doing our dy dt's here. So our dy dt's, well, what is dy dt? dy dt is negative x plus y. So I'm going to go equals negative x plus y. Okay? Alright, now this one equals negative parentheses my new x. But what is my new x? Well, it's my old x, right? Plus dx dt, which is that guy right there. Ah, that was weird. Times the step. Oh no, don't do that, idiot. So that is my new x plus my new y, and my new y is what? Well, it's the old y, right? Plus, right? Plus the delta y, which is this guy right here, right? That's the change in y, times the step, no, forget to divide your step by 2, dummy, times your step, which is $i $2 divided by 2. Ta-da! Now, this one here. So notice how this time I changed both my x's and my y's, right? Went to that new value. So notice down here, that's what we're saying right here. My x changed and my y changed, right? So that was for the first one. This is for the second one. Goes here and here, yes? It's for the second one. And so, oh yeah, this is the first one. This is for the second slope. It's the new x and the new y, right? There they are. My new x and my new y. So we'll do it again. I always cringe a little bit when I do this because honestly it's really easy to screw these things up. Man, it's hard. It's so hard sometimes. Alright, so what are we going to do? We're going to go to our old x plus our delta x, but we're going to use, which one are we on? Notice that we're on the third one over, correct? So we're going to use the second slope. Okay? Times $i $2 divided by 2, right? So that's my x plus my y, which is the old y. Oh, come back, you hippie. Plus the change in y, which is that guy right there, times, oops, divided by 2. Looks pretty good. And then this guy here is, well, it's going to be this. It's obviously going to be equals negative x. But what is my x going to be? Well, it's going to be my new x, which is at, it's that plus the delta x, which is k3, times the full step this time. Oops, come back. Plus my y, which is my old y. What a freaking mess. Plus that delta. Oh, for God's sakes, what are you doing? Stop. No, leave me alone. Piece of garbage. No, I didn't say that. Shoot. No. Shoot. Plus L2. What just happened? What are you doing? Is that D2? Is that right? No, it's not D2. It's C2. God, I hate this thing. Plus L2, which is my slope, times $I, $2. Is that an L? I guess that's an L. Whatever. Sure, that actually is correct. Yay! So there it is. So there's my average for the y's. Whew. Oh, wait. Now, the average isn't the average. I don't know why I did that way. Remember, this is a one. Remember how the average goes, friends. Over here and look at that. We did the average for this one. Remember, it's a weighted average, right? So it's 1/6, right, of those, where the two middle ones get multiplied by 2. So equals, parentheses, this guy plus 2 times that one plus 2 times that one plus that one divided by 6. Bam. Alright, so over here, notice this guy right here, right, is exactly what we want to do in the next column over. So I'm going to do equals this guy plus the delta y, which is this guy here, right, times, oops, see that? Same thing. Double click on this, copy, oops, double click on it, copy it down, copy it down, no, your fingers are too fat for that, dummy. And what is happening here? Oh, idiot, you better lock that in too, you big dope. I bet it'll work this time. Sweet. Now, I happen to have this set up for, by counting by hundredths. So, for whatever reason, I stopped at 4. It's as good as any place to stop, I guess. And so, what I want to notice is this. If I go back to my original equations over here, which I think I happen to have in my calculator, too, but so there's my calculations right there. I'm not terribly shocked that they're getting larger at all, because that's pretty much what I would expected to have happened. Okay, so what I can do is grab this guy right here, which I believe is that is y, and I can just go such that t equals 4, and I get negative 40, so something's a little screwy there. Interesting. I'm not sure that was the actual right formula, though. Maybe it is, maybe it's not. Alright. Well, we'll pause for a moment while I figure this out. So, my humble apologies. Actually, I'm going to do the other one first. I'm going to type in the x one first, see how close I am. See how close I am on x. And then we'll see if I'm going to start crying or if I just screwed something small up. Because it's possible that I just screwed something small up. And it's just, if I have it right for x, which I should be pretty right for x, then it's probably just something how I typed in the y is what's messing me up, is all it is. So I'm going to check this really quick, see if it works for this. So the problem with all this messing around is that what you end up making some stupid little mistake, throws the whole mess off, and then you're sitting there just cussing yourself the whole rest of the day. How could you be so stupid? Which, it's a good question, and when I find the answer, I'll let you know why I'm so stupid. There it is. And then a person could, if they wanted to, just evaluate this such that t equals 4. 87, and it's not 87 even remotely. So we got a little few things to work out here, and so I will try. What in the Sam Hill just happened there? Why does that one have 7 million decimals? That's weird. All right, so I will get back to you as soon as I fix this, and yeah, oh boy. All right, I hate when I do stupid things, which happens more often than I care to admit. Okay, but I like it when the stupid things have an easy solution. Geez, I wonder, do you guys see any difference between these 4 cells and the ones right below? Because you didn't copy them down, Jay, you moron. Oh, geez, I wonder if the Y's are... Wow, you idiot, you didn't copy them down at all. What a moron. Yes, I have a master's degree. I'm really smart. What an idiot. What an absolute idiot. Nice. Okay, well, okay, so, all right, now, let's go back up here. Let's see if these even sound reasonable-ish. Okay, I'm going to do something first because this is really getting on my nerves. I forgot to lock that down. So, view, I'm going to freeze panes. I'm going to freeze the top row. Boom. So now, I can come down here and take a look at it. See how far off I am, at least. But at least that would help. The idiot would actually, pay attention to what he was doing. Yeah, well, okay, so, all right, so we're off a little bit there. But at least I'm, okay, I'm going to pause you again. But I guess I'm closing in on what I did wrong. All right, I really worked really hard to find out what I was doing wrong. I still can't see what I was doing wrong on the other one. So which leads me to believe I wasn't wrong on Excel. I was wrong with my coefficients on the other problem, which is kind of sad, but it makes a lot of sense because that's probably the hardest thing you will ever do in this class. No, it's not probably. It is the hardest thing we'll ever do is solve a systems of equations that has an e to the whatever in it and a cosine and a sine. They are just ugly. There's no two ways about it. And I don't care if you're using Laplace. I mean, it's a lot easier with Laplace. Or eigenvalues, which is arguably easier than this other way, but they're all gross. Matter of fact, that's what I was doing in class today was the eigenvalue method and messed one up. So it wouldn't shock me the way that my day is going, that's what happened. But what I did is I went back and I redid this problem where x prime is just y and y prime is just x. So I went in and look, dx dt is just y. And it's just the new y. What? Did the same thing. Drug it to the bottom, and lo and behold, add x equals 4, which is what we checked it at before. Check it out. That's the values. And in fact, that's pretty much what it was on the calculator when we approximated, when we typed into the calculator and hit solve, evaluated it for on the calculator. So that makes me feel better. So Runge cut up. This sheet for systems is not this one. I want to show you this though. This one, or one similar to it, is actually on the My Courses page under Course Materials, and I believe it's called Numerical Solutions or something akin to it. But check it out. If you grab those guys and go to Insert, Scatter Plot. What? Notice how they're almost on top of each other. You can't even see them. Awesome. Be like, that's a cool chart. Could you show us something else? Love to. What if I just did these guys and graph them versus one another? In other words, don't worry about time. Worry about what x and y are doing relative to one another. And I can do that too. What? Almost a straight line. Well, what do you know about that? Now, I don't know if that's helpful to you, but then I thought, well, you know what? I'll drag up the one from last term. No way. Look what x's and y's are doing. Now, this is very similar to the one I was trying to do, but it wouldn't work. So as you can see, my x's and y's are oscillating. They are out of phase with one another. And when you graph them versus each other, you get, that's basically a circle, by the way. It's a little out of, the pitch is a little weird there. But anyway, you can see this. This is numerical systems. That's the one that is actually in the My Courses page, and you can mess with it. So it's a pretty cool deal. And anyway, if you use this one for your homework, which is what I would suggest you do, and then go in and change, all you have to do is just go in and change your initial condition there and there. I set this one up a little bit differently, obviously. And your step is way over here this time, but whatever. And then change these guys accordingly. Okay, and there, and there, all 8 of those guys. And then and make sure you copy those down, those slopes down. These graphs will update accordingly. Okay, and I think you'll be pretty impressed with the results. Let me know if you have any trouble with them. Again, shouldn't be too bad. If you start with this guy, don't try to conjure up your own. Start with this guy and see if you can make it work, because that's really what I want you to do, is to understand and feel comfortable using these things. Now, we will be using systems of equations for modeling. We will run into some that we cannot do by hand. We will also run into a few where you're like, I got it right, I got the answer symbolically. Geez, I don't know if I'm right or not. Well, you could always check numerically and see how close you are. And that's pretty much what I'm sure happened, and my coefficients were wrong. And so that's probably where I made my mistake on my symbolic solution. But again, we'll get into more of those later. None of the ones on your homework are that nasty tonight, so you should be good to go with them. So have fun with that.